Okay, the next kind of questions we tend to have are asking us to complete the square with quadratics. So, for 10a or 8a, if you're doing extension, we've got y equals x squared plus 2x plus 3. Now, don't forget with completing the square, we're just looking at the first two terms. We halve the middle one. So we've got y equals x plus, well, it's 2 on 2 squared. Take 2 on 2 squared, because if we expanded that, we'd end up with x squared plus 2 times x times 2 on 2 plus 2 on 2 squared. So we take that off, plus 3. You have done this, by the way. Hopefully you'll remember the process because I taught it much better last time. So we've got x plus 1 squared, take 1 squared plus 3. Some people like to go straight to this step instead of confusing themselves with the last one. That's fine. So we've got y equals x plus 1 squared plus 2. So this is normal quadratic that's been moved left 1 and up 2. As you can see, when we compare it with our normal one, y equals a outside of x take h squared plus k. Okay, so if we're going to sketch it, give ourselves plenty of rooms, y and x, come on, there we go. So our normal quadratic looked kind of like this, but this one, instead of being there, it's actually going to be, it's been moved left 1 and up 2, so now its turning point is here instead of down here. So I'll get rid of this and we'll put a normal quadratic looking thing like that. If we wanted the intercepts, we'd have y-intercept let x equals 0, so we'd have y equals 0 plus 1 squared plus 2, so y equals 3. So this is the point 0, 3. Hey, I did that pretty well. X-intercept let y equals 0, so 0 equals x plus 1 squared plus 2, negative 2 equals x plus 1 squared. Can't square it at no x-intercepts. Okay. So part B is we're going to treat exactly the same. So we have 10b, and the equation we've got is y equals x squared, take 2x, take 2. We're going to deal with it exactly the same. So we do x take, we're just looking at these two. What's half the second one? 1 squared. We need to subtract this 1 squared off and then minus 2. So we have y equals x take 1 squared, take 3. So it's a normal quadratic that's moved left. Sorry, no, this one's moved right 1, sorry. Right 1 down 3. If we wanted to know our intercepts, y-intercept x equals 0, so y equals 0 take 1 squared take 3, so y equals negative 2. X-intercept y equals 0, 0 equals x take 1 squared take 3, 3 equals x take 1 squared, plus minus root 3 equals x take 1, so x equals 1 plus minus root 3. We're not drawing it that accurately. So now let's do our axis, y, x. Again, normal quadratic would look like this, but we're not drawing, and well, we are drawing a normal one, we're not drawing it there. It's been moved right 1 and down 3, so now its turning points will be here. I know its y-intercept is here, so and if you can draw, it's pretty easy. And that looks like that. Okay, now let's have a look at, nope, that's it. That's completing the square with quadratics. Fairly straightforward.